Hello, I am Juan Cabrera, and I'm the State Extension Specialist for Vegetable Production at University of Missouri Extension, and I'm a Research Assistant Professor at UMKC. And today we're going to give you an overview of the different hydroponic systems that you can use to grow your crops and how to pick one for your purposes. So let's begin with defining the word hydroponic. So hydroponic is a production system that uses a medium and nutrients that are provided in a nutrient solution, right? And this medium is inert. In short words, it is a soilless production system. What people picture in their mind when they hear the word hydroponics is growing plants in water. However, based on the definition of soilless systems, you can also have these buckets or container systems that you can have something besides soil in these containers. So these are also considered hydroponic systems. You have the liquid and the solid systems. This is an overview of the different liquid systems that are out there. You have the floating raft and the deep water culture. You have the NFT systems, which stands for nutrient film technique. You have aeroponic systems. And then we have the solid systems where you have Dutch or beta bucket. We have the ebb and flow systems. And we have the wick or mat systems. Let's start with deep water culture. It's a simple construction. You have the plants supported by a floating raft, and you have an air pump oxygenating that water, that nutrient solution. So these kind of systems are ideal for leafy greens and herbs. The plants won't wilt if the pump fails because you have a huge body of water there. It's a simple construction. It requires less plants. However, it needs aeration, so you need an air pump system, a system to pump air into the water. And you end up using a lot of water and fertilizer. Still, less water and fertilizer than what you will use when you grow these kinds of crops at these yields in the field. So with a higher volume of water, it's going to be a little bit more difficult to adjust temperature, pH, and dissolve oxygen in the system, but it is doable. We have the NFT systems, which are channels or trays that hold the plants and they're slanted at a degree that the slope is anywhere between 1% and 2%. Notice that we don't have any air pump because the film of water that's traveling through there is so thin that the plants are always exposed to air. These systems are ideal for leafy greens and herbs. There's no need for an aeration system. They use even less water and fertilizers than deep water culture. And they're easier to adjust the pH and manage the nutrient solution because the water volume is smaller compared to deep water culture systems. However, there's a lot of moving parts, so they're very susceptible to leakage, and the drip lines can clog. And if the pump fails or the drip lines clog, they're going to wilt immediately because there's nothing acting as a reservoir for water. So you have to be very careful, have a redundant system, or just picture about leaving someone babysitting your plant when you go for a long vacation. Which system do you use if you're growing leafy greens and herbs? It depends on your specific scenario. The hardware and installation costs is higher for NFT systems as opposed to deep water culture systems. And NFT systems also, they end up using less water and fertilizer in the long run. And since it is a smaller volume of water, it takes less time and less efforts to adjust the pH and manage the nutrient solution in NFT systems as opposed to deep water culture. So as a rule of thumb, deep water culture will have higher operational costs than NFT, but they will be cheaper to build. So the grower has to decide what is their best fit. Aeroponics is simple construction. You have a pump and you have some misters or fogging nozzles that they spray solution directly onto the roots of the plants. They are very adaptable in terms of the design, so you can put them anywhere. They're ideal for leafy greens, herbs, and strawberries. Forgot to mention that too with NFT systems. You can do strawberries with NFT systems. So there's no need for an aeration system. It requires even less water than NFT and deep water culture systems. Like I mentioned earlier, it's adaptable to many designs. However, you need really good water quality because you don't want those nozzles to clog. Because if they clog or the pump fails, the plants will wilt immediately. And it requires a pressurized irrigation systems. So your operating costs might be a little bit higher relative to the other two systems. The Dutch and Beta bucket, you have the plants in a container and you have some sort of growing media inside those containers. Notice that I'm not saying soil, I'm saying growing media. You have some drippers and you collect that water draining from those containers and you recirculate it through the irrigation system. These systems are ideal for vining crops like or fruiting crops like tomatoes, cucumbers, melons, but you need a trellis systems to guide the plant growth and support the weight of the plants. The irrigation frequency and the nutrient rotation will depend on what you put inside that growing media. And this is a choice that it is mostly economical based on what's more available to you and what is cheaper to use in the long run. These are the different options that you can use inside those containers. You can use either perlite, you can use either perlite, Coir, Rockwool, potting mixes, expanded clay pellets, gravel. Ideally, you want to use any material that you can find for cheap locally. Sustainable is a plus, but mostly local and cheap. Notice that I have some of these materials in red, and these are materials that are inert. And this is important in terms of management. That means that the pH of the root zone is going to be the same as the pH in the water that you put in the nutrient solution if you use these materials, the inert materials. However, with the other two materials, the components of the nutrient solution are going to react with the growing media, so you cannot assume that the pH of that root zone is going to be the same as the pH of the water coming out of the emitters, because there's going to be some chemical reactions there. So I'm going to give you a brief overview of these materials. Rockwool, it was initially developed as an insulating material, but you can use it for hydroponic systems. It has good aeration. However, this is one of them that's not considered organic, even though it's only rock, because of the binder that they use to keep them in that shape. It's stable over the years, so it's not easy to compost. So you have to think about waste management. Coconut coir, this is sustainable because it is a byproduct. It was initially a waste, a byproduct of the coconut fiber industry. It is a good material, but over time it is going to decompose. It is not stable, and you have to be very careful when you buy it, because in the fiber processing process, sometimes these fibers are treated with salt, and these can end up in coconut coir. So you have to make sure that the coconut coir that you are using does not contain high salinity. And you have other growing materials like perlite. It's cheap, it provides good aeration. However, it has low water retention. That means that the pumps are going to be running more often. We have expanded clay pellets. These are reusable, stable over time. And the same with perlite, it has low water retention. They're a little bit pricier and heavier, so the pots won't tip if you're having heavy plants. Gravel is cheap, depending if you're able to get it, it can be cheap. Stable over time, it has low water retention and it's heavy. Commercial mixes that have peat, and the question there is, are they sustainable? They're still up in the air with that, but it retains water, and this is one of those materials that the pH changes over time, so you have to be able to monitor the pH in the root zone with these systems. Last but not least, aquaponics, and many people think of aquaponics as having fish and having the roots of the plants down there with the fish, and that's not the case. That's not aquaponics. It is more complex than that. This is not easy, and sometimes the fish residues may not provide all the nutrients needed for plant growth, so you might have to supplement that. This is how a aquaponic system looks like. You have different organisms separated. You have the aquatic organism in a tank. Then these organisms have waste in terms of the uneaten feed and the natural waste from the fish, and that water then moves into a biofilter where you have microorganisms transforming these waste and releasing those nutrients from that organic material into the water so that later plants can use those nutrients. And then the water can go back into the aquatic organism tank, or it can go somewhere else. So with that said, that is a quick overview of the different hydroponic systems. If you have any questions, feel free to reach out your local field specialist.